The sun does not shine on itself, and flowers do not spread their fragrance for themselves. Living for others is a rule of nature. We are all born to help each other, no matter how difficult it is. Life is good when we are happy, but much better when others are happy just because of you. If that's been the case, try to be a man of worthy, who could bring happiness and success to others. At least be someone who could bring a smile on others' face.
Man, since his existence, have been a social individual who enjoys the company of his fellows and prefers to perform his tasks collectively. As a result, he has achieved so much for all which an individual can't even dream of. In that case, if we want to make this world a wonderful paradise, or at least a place where everyone could live happily and peacefully, we have to learn how to work as a group in spite of various kinds of difficulties and differences.
Good morning, everyone. Good morning, everyone. Ladies and gentlemen, my dear brothers and sisters. Although it's just another typical day for others, it's going to be a memorable day for us. So, ladies and gentlemen, my dear brothers and sisters, this is the commencement of the presentation competition of Cambridge English Students 2024.
As a nation, we all give priority to our religions before starting any special occasions in our life. So, now let's spare a moment for religious observances.
A very good morning to all of you. It's with the great pleasure that I sincerely welcome you all for the second presentation competition organized for Cambridge English B2 level students 2024. First of all, we warmly welcome the Honorable Chief Guest, Mrs. Nishani Pereira, the Account Relationship and Business Management in British Council, Sri Lanka. It's an honor to be graced this special occasion by such an accomplished individual with abundance of noble qualities. Secondly, we pleasure to welcome the Honorable Board of Judges comprising Mr. Callum Ruparatna, veteran and well-experienced teacher of English language, and Mrs. Shashibaba Rajapathiran and Mr. Agni Fernando, who are also veteran and well-experienced teacher of science. Dear teachers, it's a rare privilege for us to versatile personalities like you all. Next, we'd like to welcome Mrs. Rasika Sanjeevani, a veteran and well-experienced teacher of science and health science. We'd also welcome Mrs. Chamila Lakmali, the proprietor of Takshila Institute in Marthagamla. In conclusion, we welcome all our beloved parents and all the brothers and sisters who are present here today for this great special occasion. Thank you.
It is essential for society to have well-trained people. But for the utmost completion of a society, it requires well-trained, well-educated people who would guide and lead through, especially in difficult and dynamic situations. So, for achieving this, the rulers of our country must develop a curriculum that not only focuses on theoretical knowledge, but for enhancing more on practical knowledge. So, with the intention of achieving various kind of future prospects, our dear brothers and sisters who follow this Cambridge English course have developed numerous essential skills, including public speaking skills, presentation skills, debating skills, and so on.
So, Today, our dear brothers and sisters have prepared to exhibit their better presentation skills representing 4 groups. They have all prepared themselves to do their best before this excited audience. However, before witnessing their performances, please bear a moment for us to introduce the board of judges. Mr. Callum Ruparatna, sir, could you please come and take your seat? Mrs. Shashbaba Rajapatirana, and Mrs. Shalini Fernand. Now, let me introduce the Junior Board of Judges. Master Tushara Hanguranketa, Miss Nidhuki Arjana, Miss Pujani Randula, Miss Netali Nishara, and Miss Gulmini Noja. Now, it's high time to initiate this colorful event. Therefore, we'd like to invite the first group led by Janudi Tamatsara. Please put your hands together and welcome them.
All these colors are called Anduri. But when we are doing the colors, actually it's beautiful. So we'll see how genetic features are used in real world. The planet Earth that we live is full of species such as plants, animals and humans and many more. If all these ones are having same appearances, how can we all identify each of them separately? So, good morning everybody, impartial of judges, dear parents and my dear brothers and sisters. Today we are here to present you about features of inheritance characteristics and how they are applicable to today's world. Think a bit, if all the students in this hall are having same appearances, so how can you identify your child separately? And the word genetic is implies the idea about the things that are transmitted from one generation to another generation, as the way that your genes are transmitted to your sons and daughters. And here are some characteristics of several Here are some famous celebrities and their parents are appeared in this screen. So these all are look like same as their parents. So that's genetics. And next up we are having our team member Gayashi and her father appeared in this screen. Their appearances are look as same as their father. Next up we have two siblings, Situmi and her sister. They both are having same appearances. So all these are happened due to genetics. And a simple gene can change the whole world. And let's see what are the features of this genetics. Kamadi will explain it.
So as Janudaka said, there are many features, common or rare, that we can see among people which are transmitted from their parents. Skin color is the most common and the most common feature that we can see among people. It might be a real fair skin or it might be a real dark skin, or somewhere in the middle like our skin, not very fair or not very dark. And another very common feature that we can see is the hair type. It can be really fair skin, like we can see in Nanukiaka's hair, or it might be really straight skin, very straight hair, like we can see Sydneyaka's hair. Speaking of hair, another feature we can see is the widow's peak. Widow's peak can be present on your hairline, like it is on Kavit Roya's hair, or it might be absent like in Shashi Roya's hair. Another common feature that we can see is having dimples. One may have dimples on your both cheeks and one may have dimples on one cheek, and there might be even one with some or there might be even someone with no dimples at all. Now I have two tasks for you. Just take your hand and cross it like this and check what finger comes on the top. It might be your left thumb, it might be your left thumb, or it might be your right thumb. That is different from person to person. And the other task I have for you is get your thumb like this and just check how it stands. It might be standing straight like my finger, or it might my finger towards like my finger. And all these features are very common among people. And now Janati Akka will explain more to you about some rare characteristics that we can see among people.
When we talk about rare characteristics, these are not commonly in humans, but rarities can be appears in society. First one is syndactyl situation. In syndactyl situation, normally we have 5 fingers. So in syndactyl situation, fingers are fused together to form this disease. And next up we have polydactyl situation. In polydactyl situation, normally we have 5 fingers, but in this situation, it's more than 6 fingers can appear, and Hrithik Roshan is example for that. Next we have albinism. Albinism occurs due to loss of pigments of melanin. And later on we discuss more about albinism. And when we come to color change of eyes, actually there are normal people having black color eyes, but rarely they are having blue color, yellow, green, or else any color for that eyes. And when we come to non-inherited characteristics, actually they are not transferred from one generation to another generation. Most of girls, including us, are like boys who are having medium build figure, 6 or 8 packs and guts. And also, most of girls are like to Bollywood heroes because of the appearance of them. So, actually, these are not transmitted from generation to generation. These are the ones they are appear due to the changes that happen in environment, nutrition patterns, and also their exercises and hard works. So those are the ones. And now Radhini will explain about Mendel's laws and monohybrid crossover bonds.
Gregor Mendel, an Austrian priest considered as the father of genetics, conducted his groundbreaking experiment in the mid-80s using the pea plant to understand how the genetic factors are inherited from generation to generation. In this experiment, Mendel chose the garden pea plant because of its easily distinguishable characteristics. He focused only one feature at a time, which is why it is also known as a monohybrid process. He chose one feature at a time and breeded, such as green versus yellow seeds, or white versus violet colors, and long or short height. Now let's dive deeper into the inherited patterns that we can observe in a monohybrid cross. In genetics, scientists use the capital letters to represent the dominant traits and the lowercase letters to represent the recessive traits. For example, we can use the capital T letter to represent the dominant feature and the lowercase letter t to represent the lowercase feature. When the two factors are similar, they are known as homozygous, and when the two factors are not dissimilar, they are known as heterozygous. For example, let's take a purebred tall plant and a purebred short plant for reproduction. When these two plants are crossed, we can have the gamete as capital T from the tall plant and simple T from the short plant. In F1 generation, all the plants would be having capital T and simple T gametes. Since the capital T is the dominant feature, all the plants will having tall characteristics. To form the F2 generation, we can get two plants from the F1 generation with the capital T and simple T gametes. When a capital T and simple T is crossed together, we can get a capital T homozygous tall plant, and when the capital T and the simple T crossed together, we can get two heterozygous tall plants. And sympathies crossed together, we can get a homozygous short plant. This is the Punnett spora, which was introduced by scientists. It can be used to easily express their two generations. Now, to continue, I would like to invite Siti.
So, patterns of inheritance using probability. We know that when two objects are combined randomly, the result always takes place according to some kind of a pattern. So, in the same manner, in genetics also, the characters from your parents inherit into children according to some kind of a pattern. And there can be some kind of a probability between them. So, for example, for a simple example, imagine that your mother is having a straight hair and your father is having a curl hair. But you are having a straight hair instead of having a curl hair. Well, what's the reason for that? Why did you get a curl hair just like your father? Well, that's because of these patterns of inheritance. So, to understand this concept further, we have to take a look at the Mendel's experiment. So, as you can see here, just like Ranmi referred earlier, Mendel's experiment, he did several experiments and this is one of them, the experiment he did using the flowers. So, first he chose a purple color flower and a white color flower, then he crossed them together. Then after the fertilization, he got 4 results and from these 4 results, 100% plants had purple color flowers. So, well, we also expect in such experiment when purple and white get mixed together, an intermediate color like pink or light purple. But actually what happened was, all the flowers were purple in color. Then to find the reason for this, he continued his experiment. He again crossed 2 flowers from the first generation and from that he got 3 flowers purple and another flower white in color. But actually he crossed 2 purple color flowers, there were not any white colors. That means in the first generation no white color flowers. But when it comes to second generation, 75% plants were purple, others were white in color. So from this experiment, he got the phenotypic ratio and genotypic ratio. So the phenotypic ratio was 3 to 1. That means 3 purple color flowers, 1 white color flower. And genotypic ratio 1 to 2 to 1. So actually from this experiment what he concluded was that there can be some genes which are present in the parental generation, just like the white color flower. And when it comes to the next generation, they are recessive. That means they are hidden. And again, in the second generation, they can be visible. So it's like a generation, that gene has skipped a generation and again came visible in the second generation. So to talk more about the basic concept of genetics, I like to invite Gayashi and Tara.
Do you know the scientist of Gutenberg? Yes, simply he cannot act the father of genetics and also is the first person who studied transmission of inherited characteristics. Mendel said that the features of an organism have special particular factor. The identified particular factor named as genes later. Genes can be divided into 2 groups, isn't it? Yes, correct. You are correct. Genes can be divided into 2 groups, heterogeneous and homogeneous. So, if 2 genes are similar, for a given organism is known as homozygous. And also, if 2 genes are not similar to given organism, is known as heterozygous. Gene expression. The information of a gene for a particular character is known as gene expression of an organism. Gene expression is a compound process. Phenotype and genotype. So, the feature externally appears or observable is known as phenotype. And also, the feature, the gene's composition or genetic makeup of the given organism is known as genotype. So, Tarani, I think DNA is very important to confirm someone identity. Is that true? And also, I would like to know what is DNA. Scientists have identified that DNA present in chromosome acts in the red gene material. So, there is a person or scientist whose found this. DNA was discovered by 2 scientists named Watson in 1952. And I would like to invite Kalku to explain heredity of DNA.
Genetically involves the transmission of inheritance leads to the next generation through genes or chromosomes. Gene linkage and uses governs the behavior of inheritance through genes and chromosomes during inheritance. The process of sex discrimination in human is a part of this inheritance. Inherited traits are coded in our DNA and genes away can be passed on to our next generation. Examples for that are hair color, eye color, height and complexion. So now we can see there are some organisms and the number of chromosomes. In pineapple there are 15 chromosomes. In paddy there are 24 chromosomes. In onion there are 16 chromosomes. In horse we have 64 chromosomes. In human we have 63 chromosomes. In corn there are 20 chromosomes. In rats usually they have 40 chromosomes, and tomato they have 24, and chimpanzees have 48 chromosomes. Now I would like to invite Sydney Akka to continue this.
Sex discrimination. A mother's joy begins when a little life is struggling inside her. When a little heartbeat is heard for the first time and a playful kick reminds her that she is not alone. In pregnancy, a mother always has to face a very common question. Well, that is whether it's a girl or a boy. Well, how can we identify whether the baby who is about to born is a girl or a boy? In genetics, we can identify this using the monohybrid cross done by the Mendel's experiment. So first, we have to look at chromosomes and sex chromosomes. We know that in human, there are 46 chromosomes, and these chromosomes exist in pairs, so there are 23 pairs of chromosomes. And the final pair is known as the sex chromosome. Sex chromosome is divided in two types, X and Y. In females, X chromosomes are always present, and in males, a Y chromosome is present. That means a male can have X chromosome and a Y chromosome, but females they can only have two X chromosomes. So when it comes to sex discrimination, when we use a monohybrid cross, we can identify clearly how the sex discrimination happens and the probability between them. Where as you can see, the father with X and Y chromosome, and then again mother with two X chromosomes. When we separate the gametes and again combine them, that means after fertilization, we get four results. X chromosome, and again two X chromosomes. Then again X and Y chromosome, X and Y chromosome. So here, as you can see, there are only two X chromosomes. That means that's definitely a girl. So here there is a Y chromosome present. If there is a Y chromosome, it definitely should be a boy. So we can say here 50% it becomes daughters and 50% it becomes son. That means you cannot exactly tell whether it's going to be a girl or a boy. There's a 50-50% chance. So also this is a wonderful creature of nature, because we cannot guess about the baby who is about to born. And also in this modern society there is a belief, and mothers are always accused for the reason that they cannot produce or give birth to a boy. But actually in genetics, and scientists have proved that mothers are not responsible for the birth of a boy, but instead fathers are the one who is responsible, because fathers have a Y chromosome with them. And if the father was able to give a Y chromosome to the mother's X chromosome, that will be a boy. But if the father gave an X chromosome instead of a Y chromosome, the result will definitely be a girl. So the sex determination is in hand of a father. So in such situations, mothers should not be accused. So to continue this presentation, I again like to invite Gayashi and Tati. Hemophilia is present in males when a wound of cut occurs. It is the blood is clogged. In that disease, the carrier is the female.
So next our topic is color blindness. So simply color blindness is the the person who cannot see color properly. As example, this is actually a dark pink paper. Out of you all, or someone can see this as purple. It's not. It's we call color blindness. So this is the most common link sex with heritage disease. So as this is mostly common in males and also rarely in females. So continue this presentation, I would like to invite Tanu.
Now, let's move into an intriguing topic that has fascinated scientists and researchers for many years: gene mutations and related inherited disorders. You see, our genes are like little instruction manuals which determine everything about us, like how we look, how our bodies function, and even our susceptibility to several diseases. Sometimes, however, little mistakes can be occur in these instruction manuals leading to gene mutations. Gene mutation can be happen in several ways. They can be inherited from our parents or maybe occur randomly during our lifetime. And they can also be affected by the exposure to different environmental chemicals and different environmental radiations. There are several diseases which happen due to gene mutations such as albinism and thalassemia. Albinism is a genetic disorder which happens due to the absence or the reduction of melanin, the pigment which is responsible for the color of our hair, skin, and even eyes. Typically, most people with albinism have very fair skin, light or white hair, and very light colored eyes. Not only human, but also animals do get affected by albinism. To talk about thalassemia, it is over to you.
Thalassemia. Thalassemia is an inherited blood disorder that goes when the body doesn't make enough protein called hemoglobin. It is an important part of red blood cells. Thalassemia is a treatable disorder that can be well managed with blood transfusions and gene therapy. The main symptom for thalassemia is anemia. There are several areas higher number of thalassemia patients like Gumnagala, Puttanama, Angadura and Kandy. Symptoms of thalassemia can be seen during the age of 15 to 19. The main unit for thalassemia patients are the unit in Kiribati. It is functioned by Ragam Hospital. The main professor there is Professor Amjad. So this is the death rate of thalassemia patients. The highest thalassemia patient death rate is during the age of 15 to 19. So I would like to invite Sasilia to continue our session.
So now let's talk about genetic engineering. In this genetic engineering is also called as genetic modification and genetic manipulation of the modification and manipulation of genes using technology. This technology is being used to produce recombinant DNA molecules with DNA fragments and with different sources. This field is known as recombinant DNA technology. It is more popular as genetic engineering or gene technology. So there are some fields that take place in gene technology, like food, agricultural, and industrial and medical fields. So now let's talk about food and agricultural fields. In food and agricultural fields, there are main two types, like genetically modified crops and genetically modified foods. So how is genetically modified foods produced? It is produced because of the creation of genetically modified crops or livestock to produce genetically modified foods. So in this table, you can see there are two oranges. The one is seedless and other one is seeded. This is because of the gene technology. So next, let's talk about instances that we use genetic technology in industrial field. They have pest-resistant crops, pesticide-resistant crops, vitamin A inversely, rice inversely, vitamin A in this border.
In this picture, you can see the better difference of normal rice and gold rice. It produces vitamin A in the paddy through a bacteria gene. And the next one is a tomato resistant cold weather. In this picture, you can see it. It means a green obtained from a fish living in cold or mud countries. And the last one is high productive fresh and with high nutritional value. The food produced by using genetically modified organisms. So next, let's talk about industrial field. In industrial field, the main applicant is bioremediation. Some organisms have transported a cell with gene coding because of using some proteins such as enzymes. But if it is did it transport with bacteria, it uses yeast, mammalian cells and insect cells for this purpose. And some instances for industrial fields that uses gene technology is production of some amino acid, production of enzymes production of enzymes and amylase, production of vitamins by cyanobacteria, examples like vitamin B12 and vitamin E. So next I invite Kamali to continue our presentation.
So, apart from the contribution done to the food, agriculture and industrial fields, genetic engineering has also done a great contribution to the field of medicine by allowing researchers and medical professionals to understand better and treat various diseases. One of those treatments is gene therapy. This gene therapy makes it possible to replace genes which are responsible for the genetic disorders with some new and healthy genes, and that makes the patient healthy. And this gene therapy is also used in cancer treatment. Some genes are introduced to some cancer cells, and hoping that those genes will destroy the cancer cells and the patients will be healthy. Another instance that the genetic engineering is used is in the production of pharmaceuticals. And so, example for those pharmaceuticals is the production of insulin. Not only that, genetic engineering also helps in production of many other pharmaceuticals by adding genes, bacteria, yeast or another organism. You may have seen that in crime scenes, police take some DNA samples for investigation. That's because by checking the compatibility of the DNA sample and that of the suspect, the culprit can be easily identified. And now to sum up our presentation, I would like to invite Sasirai.
As all described above, our most technology is developed day by day, and also the DNA and this inheritance technology also increase by day by day. So as example, there are more animals that are combinations of genes from several animals, and also there are plants which are having combination of some kind of potato and tomatoes, and also brinjals and tomatoes. Likewise, and also there will be some animals who are yet not discovered. But what happens if their qualities are bad? It kind of a bad to whole world. It's a destroy the whole world. So think a bit, and what we want to tell to all of you is use this genetic technology as much as possible for the well-being of the real world. And thank you.
In life, we may encounter lots of challenges, hardships, and even pain. When life says give up, hope always whispers, saying try one more time. Why not believe in our own hopes? Now, we'll invite Tinuli Induri to fill our minds with motivation.
Who thought a single apple fallen on a random man's head would fill books with confusion and nonsense? Well, for the most people, it's curiosity and a solution for most problems. Well, how did this single apple change the world of science? I invite a team led by Senoni Dimansa to express this question with an answer.
Yes, I'm going to. Oh my god. Why did the one have to be fallen on that guy? You know, yes, what's wrong with that? Then next year I'll have to study about teamwork and I think it's very hard for me. Don't worry, Sukamali. Our team Oceanians will teach you that lesson. So, be careful. Okay.
One day, a man was sitting under an apple tree. Suddenly, an apple this has fell onto his head. Yes, I know. Most of you know about this story. Yes, that is the world's best and well-known scientist, Sir Isaac Newton. So, what could he thought at that situation? Yes, he had got many ideas onto his mind. But this like history of the physics. Can you imagine it? Why not? It has happened. So, how it would be? Today, our team Motionians are going to explain you all about that. First, after falling that apple onto his head, Newton was discovered about the gravity. As you saw, I throw up this apple and catch it. Yes, that is because of the gravity. But thereafter, Sir Newton has discovered the most important laws of motion. There are 3 laws of motion. So, after that, before that all, good morning everybody. Dear Chief Guests, the Honorable Board of Judges, and my dear parents, my dear brothers and sisters. As it on the screen, today our topic is Newton's laws of motion. Sir Isaac Newton, as I told before, discovered 3 laws of motion. Most of the students may think that, oh God, how good if he had written that down. So, there will no more be those laws of motion. So, do you all think that? Is it good? No. But he discovered the most important things in physics. We can deal with them combined with our daily life. Thereafter, you can learn it simply. So today, we are going to prove it. Newton's first law of motion. There are 3 laws, but no more. I'm going to explain you all about that. As I told, my team is ready to do that. The first law of motion is going to explain by Chamal Shah and Sachin. So let's invite them.
Wait a minute, Sachin. How is this move very fast also?
Chamasha, we all play carom in our life, and for in this world, for everything, there is a scientific reason. For this course, there is a scientific reason. What is it? When we striking on the carom disc on the carom board by our fingernail, it moves a short distance. But when we apply some talcum powder onto this carom board, it will move a long distance before coming to the rest, because the carom board surface is smoother. Why? What is the reason? The reason is the action of talcum powder reduces the resistive force that exerted on the carom disc on the carom board. The resistive force that opposes that the object of an object on a surface is called as friction. When we make the frictional force equal to the 0, then the disc will move without stopping. For this scientific reason, Newton invented a law. It's called as Newton's first law.
Until an unbalanced force is applied on it, the body's address remains stationary, and the body's in motion will continue. That is Newton's first law.
Maybe you didn't get a direct idea about this law. So from these 2 video examples, you can get some more idea. You can see this force is when the unbalanced force is applied onto this body address, it's moved to start.
And the body of motion will stop with the force.
For more information, we are moving to the another 2 examples. You can see this little boy is kicking to this ball, that the ball at rest start to move.
And in the second example, as you all know, the seat belt exerted a force to the upper part of the body, but when weight applies the motion of the seatbelt will stop falling forward.
Newton's invented not only first law, he invented another two laws. Now Himasha and Sidhu will explain about the Newton's second law.
So Sachinyaka and Samanchaka told us about the Newton's first law. So now, can you teach me about Newton's second law?
Of course, Malik. Listen carefully. The acceleration of a body is directly proportional to the unbalanced force acting on it, while it is inversely proportional to its mass.
So that means when the force is low, the acceleration is also low. And when the force is high, the acceleration is also high. Also, I think when the mass is high, the acceleration is also high. Is that right?
Yes, Malik, it's right. And next, we have to make the equation. And this is acceleration is directly proportional to force, and also acceleration is inversely proportional to 1 divided by mass. Then after, acceleration is directly proportional to force divided by mass. After that, force or mass is divided by acceleration equal 1. Then after, force divided mass equals acceleration. At last, we can get the equation as force equals mass into acceleration. That means F equals ma.
So are there any units for this?
Of course, Mali. And for acceleration, it is ms minus 2. And for the mass, it is kilograms. And for the force, it is n. That means newtons.
Can you do any calculation regarding this?
Yes, Mali. Let's see some. And here's the question. What is the force required to give an acceleration of 4 ms minus 2 to the 10 kilogram mass? So, to make this, we need the equation. And we know equation. That is F equal ma. And F means force. So, we haven't given here force. So, F equal m. M means mass. And we have given here mass. We get it. That is 10 kilogram into A. A means acceleration, and we also have given acceleration. It is 4 ms minus 2. We multiply it and we can get the answer as 40 kilogram ms minus 2. At last, we can get the answer with the standard units. Force equal 40 newtons.
Should we try one more?
Of course not. And this time, let me give you a question and you need to answer it. Is it alright?
Okay.
And here's the question. A force of 10 Newton is applied on a body mass of 5 kilograms, moving at a uniform velocity in the direction of its motion. So, Situmali, find this acceleration of the body.
So the equation is F equal ma, and we have the force and the mass, which are 10 Newton and 5 kilograms. To find the acceleration, we need to divide the force by the mass. So when 10 kilogram ms minus 2 divided by 5 kilograms is 2 ms minus 2. That means it is the answer.
So Mani, let's make one more question. You answer it well. So here's the question. If an acceleration of 3 ms minus 2 results when a force of 6 Newton is applied on a certain object. So find the mass of the object.
The equation is F equal ma, and we have the force and the acceleration. The force is 6 Newton and the acceleration is 3 ms minus 2. So 6 kilogram ms minus 2 divided by 3 ms minus 2 is 2 kilograms, which is the mass.
So Situmani, you can now solve this question.
So are these the examples for the?
Of course, Situmani. There are lots of examples, and let me give you 2 examples. One is lifting weight and other is a football player kicked a ball and lots of football players kick it to another direction. So Situmani, can you give me some more examples?
When obviously people are walking, their acceleration is low because of their high mass. And when we punch something slowly, it doesn't move a lot. And when we punch something hard, it does move a lot.
So, Sidhumal, now we get to know about the Newton's second law. So, let's give the chance to Tharul Aya and Manati Akka to tell us about the Newton's third law.
How was that?
Not bad. Is this scenario also based on Newton's law?
Yes, it's Newton's third law. It is, for every action there is an equal and opposite reaction. So can you explain about action and reaction?
Yes, of course, sir. Action means the force exerted by an object on another object. And reaction means the force exerted on the first object by the second object. So, can you give me some example of third law?
Yes. Then going boat riding, then swimming, and blowing balloon, and shooting are some examples.
So now we have done the most important part of this lesson. So it's time to talk about momentum. I would like to invite Hiroshinanga and Saki to explain about what the momentum.
Hiroshinanga, catch this. If I pass you a big stone, can you catch like this? No, I can't. Do you know the reason for that? I don't have any idea. Can you explain it? Sure. The main reason is momentum. The momentum of a moving body is measure of how difficult it is to stop the motion of the body. And there is an example for momentum. What is this? It is called as Newton's third. And there are two examples also. They are swinging and hammer throwing. Sachini Akka, I told everything about momentum. Can you please get some calculations of this because math is too hard for me. What's nothing? There is a specific formula to calculate this momentum and specific symbols also. For momentum we use V, for mass we use M, for velocity we use P. And there are specific units also. For mass we use kilograms, which means kg. For velocity we use ms minus 1. And when we calculate the momentum we use the unit kg ms minus 1. Now for the more explanation we are moving to an example. A bullet of mass 20 gram fired by a gun moves at a velocity of 400 ms minus 1. Find this momentum. First, we want to apply the details in the question into the formula. When we are applying the information in the question into the formula, this given the mass in gram. Firstly, we want to convert it into the kilograms because I told you before there are specific units to calculate this momentum. So when we are convert the gram into kilogram, after that we want to multiply it by velocity. Then we can get the momentum as 8 kg ms minus 1. Now Chamansha and Sahanya will explain about the differences between mass and weight.
Wow, wait a minute. When I'm on the earth, my weight is 48 kilograms. But when I'm on the moon, my weight is 8 kilograms. So why? What is the reason for that?
Did you see what happened in the beach? The astronaut is very happy. She's jumping and she's very joyful. But suddenly she got exhausted. Why? What is the reason for it? That is that she thought that her weight in the earth is 48 kilograms. But in the moon, it's only 8 kilograms. Why? The reason for that is weight. The force which used to measure weight. This is called spring balance. And this is the equation for the weight. It means mass into acceleration. So, mass. Mass is not like that. It is not changing like weight. Now, can you explain me about mass?
Okay. As you all know about mass, mass is the amount of the amount in an object is called mass. So, do you all know the measuring mass of the equipment were scales balance and or the triple balance? So, the international unit was defined in 1795 as kilograms, and the simpler form is to measure the kilograms was kg. So, I think that's all. No?
And now I can say you that in here the mass is not changing. You also can see the mass is not changing when it is on the earth. The mass is 50 kilograms. On the Mars, the mass is 50 kilograms. On the moon, the mass is 50 kilograms. All are same. Right?
Yes, you all can see in these diagrams. The mass is equal all the diagrams, but weight is not equal. They are different from each other. So what is the reason for that? The reason is the change of gravitational acceleration. So that's why mass is equal all the diagrams, but weight is different.
Okay. Now let's move to summary.
Okay, we think that you all have a clear understanding about 3 laws of motion and some extra things. Now it's time to have a look on the summary. So now it's time for food.